When you think of science, what pops into your head? Probably proving things, right? Stamping something with a big, yes, this is a fact. But what if I told you the real power of science isn't in saying yes at all, but in its ability to say with absolute certainty, no? To get our heads around this, we've got to ask a super fundamental question. What is the actual job of a scientific law? Like the law of gravity or the conservation of energy. Well, the gut reaction, the one most of us would probably have, is that a law is there to confirm what we see. Its job is to tell us what is true. But, and here's where it gets really cool, a deeper look at how science actually works tells a totally different story. The real job of a law isn't to confirm things, it's to forbid them, to draw a line in the sand and say certain things are just plain impossible. So this completely flips the whole idea of scientific proof on its head, right? It's not about just stacking up an endless pile of confirmations. The real muscle of a scientific theory comes from a much more demanding and, frankly, more powerful idea. The key thing to grasp is this. A law isn't powerful because of what it allows to happen. It's powerful because it makes a really bold, really specific claim about what cannot happen. It basically sticks its neck out and dares the universe to prove it wrong. All right, so let's really unpack this idea of laws as prohibitions. How does that even work in practice? Well, it turns out you can rephrase pretty much any universal law into a very specific kind of statement. And that statement is what's called a non-existence claim. A truly scientific statement doesn't just say, all swans are white. It makes a way bolder claim. It says a black swan does not exist. See the difference? It's denying something's very existence, and that's where its power comes from. Let's take an example we all know, the law of conservation of energy. We usually think of it as, energy just moves around, it doesn't disappear. But if we reframe it as a prohibition, it becomes this incredibly powerful statement. A perpetual motion machine is impossible. The law flat out forbids it from existing, period. And this isn't some one-off trick. This principle is all over physics. Take the law of quantized charge. It's not just a dry statement that charge comes in little packets. No, it's making a universal prohibition. It's saying you will never, ever find a charge that's like 1.5 times the basic unit. It's another absolute no. So why does all this matter? I mean, who cares if we say all energy is conserved versus no perpetual motion machines exist? Well, the answer gets to the absolute bedrock of science, the idea of falsifiability. And here is the absolute key insight. For any statement that's supposed to be true everywhere, for all time, there's this fundamental imbalance. You can never, and I mean never, prove it's 100% true, but you can prove it's false. Just think about it for a second. To prove all swans are white is totally, completely true, you'd have to check every single swan that has ever lived and ever will live. Across the entire universe, it's literally impossible. But to prove it's false, all you need is just one single black swan. That's it. That one counterexample demolishes the entire theory. That is a test we can actually do, and that's the logical engine of the scientific method. Okay, so this brings up a really interesting question. If the gold standard for a scientific theory is that it could be proven false, what do we do with statements that can't be? Let's take the opposite kind of claim. A white raven exists. To prove that's true, easy. You just need to find one. But how would you ever prove it's false? You'd have to search every nook and cranny of the universe for all of time and come up empty. It's impossible. So that claim is non-falsifiable. It's outside the bounds of what we can test with science. It lands in this category called metaphysics. Hey, it might be true, but we can't design an experiment to disprove it. So what's the big picture here? How should we think about what science is really doing? It's not just, adding bricks of truth to a wall. It's actually a lot more like being a sculptor. And this is just such a brilliant way to see it. Science defines what's real by chipping away everything that's impossible. Our picture of reality gets clearer and more defined, not by adding things, but by taking away the things that can't be. Every single prohibition, every falsifiable law is like a blow from the sculptor's hammer, knocking away a chunk of the impossible and revealing the true shape of reality underneath. And this brings us to the ultimate point, and it feels a little backwards at first, but it's absolutely true. A theory that forbids almost nothing, well, it tells us almost nothing. But a theory that forbids a ton of stuff, one that makes really bold, specific prohibitions, that's a theory that's packed with information about how the world really truly works. Its strength lies in how much risk it takes. So this leaves us with a pretty mind-bending thought, right? All of modern science, everything we've built, is resting on a foundation of powerful no's. And it just makes you wonder, which of the things we currently think are impossible aren't? What forbidden discovery is sitting out there just waiting for someone to find it and completely change the game all over again?